Hi, I'm Dr. REHMAN JAMI. This lesson is on derivatives. In this lesson, we shall know how to differentiate a product of two functions. The derivative of two differentiable functions, the functions we are taking for differentiating, the product we are taking for differentiating, each one of them is a differentiable function. So, the derivative of two differentiable functions, so function should be differentiable, then we can differentiate. And this is uv. If I have f of x equals uv, that is two functions are multiplied and we want to differentiate f of x. So formula is so simple. We write f prime of x equals, we differentiate this function uv, derivative of u and v. First function, derivative of the second function, plus second function as it is and derivative of the first function. This notation may be tedious for students sometimes. So I give you an easy way of writing this one. The way is so simple, just write on uv prime equals u, first function keep as it is, derivative for the second function plus derivative of the first function and keep the second function as it is. So we write uv, you can say, I just write in both cases uv and uv. First place we differentiate v and second place we differentiate u. And before applying this rule on any function, I would like to remind you the basic formula for differentiation, which is x, and if we want to differentiate x raised to the power n, in which x is a variable and n is a constant number. So simple it is, and x raised to the power n minus 1. So we here write first this exponent and then x and minus from this one. For example, we have derivative of x raised to the power 5 with respect to the same variable x, independent variable this we say, and this will be same. So the same formula we apply, we write 5 and x, 5 minus 1, which is 4. One more thing before starting the concept, applying this concept, we have, for example, 5x raised to the power 3. Here, this 5 we keep as it is, we don't differentiate. We differentiate only this x raised to the power 3. And x raised to the power 3, applying this formula, is 3x raised to the power 2. So 3x, 3 minus 1, which is 2. So final answer is 15x raised to the power 2. So this is the derivative for the function 5x cubed. This is the basic rule, so you must remember before starting a product rule. So first example we practice, derivative of this function we have to calculate. F of x is 2x plus 3, 2x minus 4. You see, this is the product of two functions, just like u and v. And here you can see first one is 2x plus 3 and 3x minus 4. Same, this is u and this is v. So the best way before applying this rule, don't write this formula directly over there. Before applying this rule, you write down first one equal to u, which is 2x plus 3, and this is v, 3x minus 4. You know by this rule how to differentiate simple functions. So differentiate this one. This is 2x. 2 is a constant, stays as it is. The derivative for x is 1. So 2 times 1. And constant term, its derivative is 0. So u prime equals just 2. The same is the case in v. Derivative of x is 1. Constant derivative is 0. Simplify, v prime equals 3. So now we have u and u prime, v and v prime. According to the rule, you see, first term should be u times v prime. So we multiply this one. Just do the cross multiplication in brief. No need to go in the depth and no need to remember the formulas. So simple is just multiply, because when you multiply you can see here u times v prime and u prime times v. This is the same thing. So just we multiply them and you see 3 times 2x plus 3 plus 2 times 3x minus 4. Now we simplify by distributing log. You can see this is 6x plus 9 plus 6x minus 8. And after simplification, like terms are added. This is a like, these are like terms. 6x plus 6x, 12x, and 9 minus 8 is plus 1. So this is our final answer of this one. So f prime of f of x is 12x plus 1. Let's try another example. In this example, we have been given function fx and we have to find f prime of x. So you can see this is product of two functions, 2x squared minus 1 times x cubed plus 3. So say the first function u and second function is v. So we write separately u equals 2x squared minus 1 and v is x cubed plus 3. Now we can differentiate. So u prime you have, you know, is 2x squared is 4x. And here v prime you see by applying the basic rule 3x power 2. So we have now u prime, v prime. So because this is the product of two functions, so f prime of x is just cross product of these functions, nothing else. So I multiply these functions, 3x squared 2x squared minus 1 plus 4x times x cubed plus 3. Cubed or cubed as you like say. Now we just simplify. Differentiation is over, derivative is over, but we have to simplify. So this gives us, by distributive rule, you can see this is 6x raised to the power 4 minus, this we multiply 3x squared plus. Same method we repeat here. Distributive multiply with this one, number is 1. So 4 times 1 is 4, x times x cubed, x4, and we multiply here 4 times 3, 12, and no variable, so x stays as it is. So multiplication done. Now we have to look for the like terms. You see here this term and this term. These are like terms. So we can simplify 6 plus 4, 10 variables stay the same, x raised to the power 4, x squared is only one term, so 3x squared plus 12x. We see x is common in all the terms, so it's best write down x 10x raised to the power 3 minus 3x plus 12, and this is f prime of x. Okay, so this is the derivative of the given function f of x, which is product of two differentiable functions. These both are differentiable functions. Remember, that's why we have this one. One more example. This example is a bit difficult, little higher level as compared to previous examples. Here we have a function f of x, which is a product of two functions. Of course, the function we are taking here, this one and this function, these both functions are differentiable. The first technique I told you in this one is write down these functions separately. I write the first function u, x plus 1, and v, 2x squared minus 3x plus 1. Now we shall differentiate separately and cross multiply. That's it. So here we have u prime, x derivative is 1 and 1 derivative is 0, no need to write. V prime we differentiate 2 constant before variable, so keep as it is. X square derivative is 2x, so this comes 4x. Minus 3 is a constant before a variable, so we keep as it is and find the derivative of x. So this comes -3. And derivative for 1, which is a constant number, of course it is 0. No need to write. Now, simple, we cross multiply these functions and we can write down f prime of x, which is x plus 1 times 4x minus 3 plus 1 times 2x squared minus 3x plus 1. You see here, just cross product is giving us the derivative of these functions when we differentiate them separately. Okay, now here you can simplify x, multiply the first one, 4x squared, x multiplied with the second, minus 3x. Now, second term we multiply, plus 4x, and then this is minus 3. Apply the FOIL method for multiplying this one. Here, because one time anything is the same, so keep 2x squared minus 3x plus 1. So multiplication is done. Now we have to look for the like terms. Next step is look for the like term, simplify and write the answer. X squared here and x squared is over here. So 4 plus 2, 6x squared. This is, you can see, these terms are taking x. So, like terms. -3 and plus 4. Plus 1, positive 1. And 1 minus 3, minus 2. So, this is minus 2x. And how many constants? We have two constants here. One is this one and one is over here. So -3 plus 1 minus 2. Now we look, if any number is common to them, take it out. So this comes to 3x squared minus x minus 1. You can leave here, no problem. It's up to you. So this is f prime of x. So this is how to find out derivative of a function when it is product of two differentiable functions. So I repeat it again. Product of two functions is given. Write first u, second v, differentiate them, and just do the cross multiplication without remembering the formula. No need to remember it. And multiply and simplify and find the final answer.